Hello friends, today we are going to see LeetCode easy problem to find a single number. So let's understand this problem statement. You are given with a non-empty array of numbers and every element in this array will appear twice except the one number. And we have to find that single one. Okay, and another condition is you should implement the solution in a linear time complexity and you should use constant extra space. Okay, let's see the example. So in this array we have 1 for one time, so the output written by this is 1. Let's see the second example. In this array 4 appear for one time, so the output is 4, and in the third array 1 is appearing for one time, so the output is 1. So for this problem it's given that the given array is going to contain one single number, and if there are any other numbers they will appear twice. So let's see our first approach. Okay, in first approach what we are going to do, we are going to have a hash map. Okay, we'll create an empty hash map first and we are going to iterate the array. So 4 in the array, it's not present in a map, so we are going to insert a 4 in map and it's appearing for the first time, so its occurrence will be 1. Then we will get 1 is not in a map, insert 1 in a map with occurrence 1. Okay, then 2 appear in the array, 2 is not in a map, we are going to insert 2 with occurrence 1. Okay, then we got 1 in the array, 1 is already there. What you need to do is increment this occurrence to 2, and now we see 2 is already in a map, we'll increase the occurrence from 1 to 2. Okay, once we are done with the iteration of this array, we will iterate the map and we will check which element in this map has the occurrence 1, and once we get that occurrence 1, we'll return the number 4. Okay, so the time complexity for this problem is order of n because we are iterating the entire array. The space complexity can goes to maximum of n by 2 plus 1, but it will boil down to order of n. Okay, so let's implement this solution and then we'll see another approach. So what we are going to do is we are going to create a map here, integer, give the name map is equal to new hash map. Okay, now we are going to iterate this num array. Okay, now what we are going to do is we are going to put the number in the map and we'll try to get its previous occurrence. If it is for the first time, then it will be set default to 0 and do plus 1. Okay, so after this we will have our map something like this. Now we need to iterate the map. Let's iterate the map. Key and map dot key set, and what we are going to do is we are going to check if map dot get key is equivalent to 1. If it is equivalent to 1, then you are going to simply return that key. Okay, so it's guaranteed that you are going to get at least one number which will have the occurrence 1, and if you don't enter in if, then it's an invalid case. We will not have any invalid case, but we have to return some integer number. So here I'm going to return -1 in this case. Let's try to submit the solution and let's see whether it worked or not. Okay, it worked for the basic test case. Let's submit it. Yes, it's ran for the entire test cases. Okay, But we are also given in the problem that we have to implement the solution in a linear time complexity and we have to use a constant extra space. Here we are using the map, which is a extra space of complexity order of n. Okay, let's see another approach which will have no extra space. Okay, let's see the approach 2. Approach 2 use a bit manipulation operation, XOR. Okay, so let's see how this XOR work. XOR work on a binary data, that's a bit. Okay, so if I do a 0 0 XOR, it will be 0, 1 1 XOR will be 0, and 0 1 or 1 0 XOR will give me 1. Okay, let's see how we can implement it for this problem. We are given with an array. We are going to take one number n which will be set to 0. Now what we are going to do, we are going to iterate our entire input array and we are going to continuously do XOR of the n with the number in the array. Okay, so let's see how it works for this array. Initially n will be equal to 0, then we get first n as 4. When we do XOR, these are the binary data for 0 and this is a binary data for 4. When we do the XOR of 0 and 4, this is what we get, and this will be our new n. And then we are going to pick up the second number 1 and we are going to do XOR with whatever the result we got after the first iteration. When we do XOR with this, we will get this, and that will be our new n. Okay, then we'll do XOR with 2, and this will be the output which will store in n. Then we'll get 1 and 2. Okay, we will do XOR of 1 with the previous result, we'll get this number, and we'll do XOR of 2 with the previous n and we will get 4. So what is happening here, if you look at XOR operation, the number of bits and number of bit in this one and this one is going to be same. When I do XOR of any two same number, is going to give me the output as 0. So this XOR with this one, both 1 will give me output 0. This 2 and this 2 XOR will give me output 0, and 4 XOR with 0 always give me the given number, that is 4. Okay, it's very simple algorithm, and let's try to implement that algorithm. What I'm going to do, I'm just going to delete this and I'm going to take one variable n which will be set to 0 for take the number from the array using a for loop nums, and here I'm going to do n equal to n XOR with num, and when I'm out of this for loop, I'm simply going to return n. That's it. Now let's submit this solution and see whether this works for the basic test case. Yes, the algorithm is working. Let's submit it for all the test case. Let's see this. And if you look at the time, it's much faster compared to the previous one, and we are not using any extra space. See, it took 23 milliseconds for our previous algorithm, and now here it took only 1 millisecond. Even if you can see, the difference in memory is also reduced for both the algorithm. Hope you like this problem and its solution. If you like my video, please do subscribe to my channel. Thanks for watching.